Hi friends, this is Vishal Malik. From so long, I was thinking to start a series on data structure, and first topic which strikes my mind was sorting. And in sorting, we have different algorithms like selection sort, bubble sort, and so on. But before starting those algorithms, I actually want that we all should go first that what actually sorting is so that we can understand our algorithms in much detail. So for this series of sorting, I will first start with the definition of sorting, and then I will cover the different types of sorting, and finally the applications of sorting that will be covered here. From the point of view of definition, I actually went through the different websites like Wikipedia and some of the dictionary websites, and these are the definitions that I'm showing here are actually from those websites. So first, if we go from Wikipedia, and I found out that sorting is the process of arranging items systematically. This means if I am arranging something systematically, then that is called sorting. For example, that on my study table, if I am arranging different things, that I am arranging pens, pencils, and rubber, sharpener in some area, and have books in some other part of it, and I have the notebooks on some other part, then actually it is a sorting or arranging of items systematically. So this is what the sorting is. And then from the Collins dictionary, it is there that the process or the operations of ordering items and data according to the specific criteria. So if I am putting some criteria for ordering of items, like I have different colors of balls, and I want to arrange them on the basis of the different colors, like I have red separate, blue separate, green separate, then this is a criteria. I may have some other criteria like the weight of the ball. So if the weight of the ball is less than 100 grams, I'll put them in separate box. If I have a weight between 100 to 200, I'll put in another box. Then above 200, I'll put in another box. So this is another way of categorizing it. So I am specifying a separate criteria. So it all depends on which criteria that I am choosing. And from Oxford Dictionary, that it is there that a range of systematically in different groups, and maybe that we are separating it according to the type, that what type is it. So that is what the sorting is all about. So if we combine them together, it is actually that when we are arranging our items systematically with some criteria or type associated with it, that is what actually called as sorting. So, from the definition, if we understand, there are two ways that we understand the sorting is. One is the ordering, and second is the categorization. So, ordering, as we understand from our computer science perspective, that when we have items which is in ascending order or descending order, so that is what is ordering of items. Like if I am arranging my array in ascending order, so that is ordering of items. If I have a dictionary, and in my dictionary my all words are arranged in alphabetically order, so that is also the other way of ordering it. And if we think from the categorization perspective, that is we are arranging some items as per the different types or size. So that is what the categorization means. For example, that I have different bins and I am sorting my items like paper, plastic, and cans with the different bins so that I can recycle them. That's also the way of sorting it or categorization. So ordering and categorization are the two ways of sorting our items. From computer's perspective, if we understand, we can say that our sortings are either internal sorts or they are the external sorts. So from internal sort, it actually meant that if our whole process of sorting, that is arrangement of the items in either ascending or descending order, takes place in our primary memory, which is our RAM in case of computer. So that is what the internal sort means. Means our whole process of sorting happens within the RAM itself. And if we say the external sort means that we have more items. The items are uh, too much that we cannot put them in the RAM. So some part will reside in the RAM and some part will reside in the hard disk or the secondary memory of the computer. So if we say that the complete process of sorting will not take place in our primary memory, so the some part of the process takes place in the secondary memory also. That is what the external sort, because it is external to the primary memory. So if we understand the examples of internal and external sort, and we saw it here that for example, in our first case, we have different numbers, and all these numbers are present in RAM, and these numbers are 4, 3, 14, 32, 1, 19, 59, 37, 83, and 22. All are residing inside the RAM only, and we can sort them within RAM itself. So this is the example of the internal sort. But if we have more numbers, means the more than lakhs or 10 lakhs of numbers are present, and we want to sort them, so we will sort them on the basis of chunks. So we'll do one thing, we'll sort some part. After sorting some part, we'll put them back to the hard disk, and then we'll take the another unsorted list, put them back into the RAM, sort them again, put that part into the hard disk, and in this way our the whole process of sorting will happen. So this is what the external sort means, because the external sort involves hard disk, that is the secondary memory. So the speed of external sort is always slower than our internal sort, because our primary memory is very much faster as compared to our secondary memory. There is another way of sort process. So one way of sorting them is called the stable sorting process, and another way of sorting them is called unstable way of sorting it. Now, the stable way of sorting means that whatever the input I am giving, and that input may have the two numbers which are same. And if those two numbers are same and in our output they are in the same order that in which the input is given, so that is what the stable sort is. Means the process of sorting the elements where equal elements appear in the same order in output as it appears in the input. We'll understand this a little more when we actually go to the example. And just like the unstable sort means the output may not be in the same order as the input is of the equal elements. Means when the elements are equal, even then the in the output they are not in the same order in which the input is coming. So let me, I think so, understand this with the example, just like this, that we have the unsorted list of elements here, like pineapple, apple, banana, papaya, and orange. So this is the unsorted list. We want to sort them on the basis of the first letter. For example, that in first case is P, A, B, P, and O. I want to sort them. And so in this case, the apple will become first, and then banana, which is starts with B, and then orange. And after that, it will start with P, which is pineapple or papaya. Now, if pineapple came before and the papaya came second, so then we call them as a stable sort because in our input means in our unsorted list, the pineapple is before papaya. So this is a stable sort. In case of unstable sort, the output will not be the same as the input for the same type of elements. For example, in case of unstable sort, when we are sorting the elements, all the first three elements are same like apple, banana, and orange. And after that, there are two words for which starts with P, which is papaya and pineapple. If papaya came first and the pineapple came second, so it is unstable sort because in input the pineapple came first and papaya came second because now the order changes, so it is an unstable sort. If we go for the applications of sorting, there are different applications of sorting. First is the searching efficiently. We know that for the different searching process like binary search, if we go that it always want that the list should be sorted. So it will always be efficient when we go for the binary search. Similarly, if we are merging the sequences and we want to get the resulting as a sorted element, like in merge sort, we want the sequence to be merged together. So that is the merging of sequences. So that is also one of the application of sorting. Then, for example, we want to process something in a defined order. Like example, earlier when we understand that what sorting is and we have the different colors of balls, we want to first process blue balls, then we want to process red balls, then we want to process the green balls. So this is the defined order. So that is also if we sort them, then we can use this. For example, we want the duplicates from a sequence. So to get the duplicates of a sequence, it is always good if we sort the sequence. If we have the sorted sequence, it's easy to find the duplicates. And if we want the smallest difference between the two numbers of different items, then the better solution is that first we'll sort them and then the numbers which are adjacent, we can find the difference together and see that which has the smallest difference. So this is the way that we can have the different applications of sorting. I have the references from the different websites like Wikipedia and the Art of Computer Programming by D. Knuth. Uh, just to let you know that my next video will be on selection sort, in which we actually understand what is the algorithm for a selection sort, and then we go for program it and actually execute it and find out that yes, it is working good or not. So just to help me with, just share your comments for this video, and so that I can understand that how this is going, or if you have any doubts or any queries, you can still put it in the comments. Yeah.